Companies across industries and around the world are investing billions into blockchain technology. Jones Day's Jim Cox co-edited the American Bar Association book, Blockchain for Business Lawyers, and he's here to talk about blockchain basics, what it is, how it works, and its current and future applications. And we're also going to discuss a Mr. Satoshi Nakamoto. He started the blockchain movement 10 years ago, and now no one even knows where he is. You can't make this stuff up. All that coming up. I'm Dave Dalton. You're listening to Jones Day Talks Technology. Jim Cox is with us today from Jones Day's Business and Tort Litigation Practice. Based in the firm's Dallas office, Jim works with clients on complex technology-related issues. Lately, Jim has focused a lot of his attention on client matters involving cryptocurrencies, blockchain, and other applications of distributed ledger technology. Jim is also the co-editor of the very recently published Blockchain for Business Lawyers, a comprehensive guide to the legal issues relating to blockchain technology. It was published by the American Bar Association. Learn more about the book at americanbar.org on the Shop ABA tab. Jim, first, congratulations.
Thanks. I really appreciate it.
That is no small thing. In fact, when we were made aware of this project earlier in the year, someone from our department said, well, we wrote the book on blockchain, but we literally did. What was it, 17 Jones Day lawyers plus you and Mark Rasmussen doing the editing. How did all this come together?
Well, we had started a project here in our office in Dallas. Mark Rasmussen and I have been investigating blockchain technology and trying to figure out what the legal problems are likely to be for clients that Jones Day might have. And about a year ago, one of our partners, Jay Johnson, who's in the leadership of the ABA's Science and Technology section, told us that the ABA was interested in a book on blockchain technology. So we actually pulled together a proposal pretty quickly. And to do that, I reached out to a couple of dozen lawyers around the firm. And we were able to put together a team with a lot of expertise in the different ares that we needed. We gave the proposal to the ABA. They approved it. But then they told us we had to write the book in about 6 months.
Oh, sure.
So we did that. Somehow we were able to get that done. And it's just been published last month.
Yeah, I'm looking at it. I have a copy right here on my desk. It's a doorstop, 240 plus pages and something like 8 chapters plus an index. Very comprehensive. I will not be dishonest and say I've read the whole thing, Jim, but I've skimmed it and it's great work. So congrats again. And we'll talk more about the book in the weeks and months to come, I know. Let's talk about blockchain specifically. And that's sort of a go-to buzzword. We're reading a lot about blockchain in the business media, and it's just on the verge of sort of mainstream knowledge, I guess. But for the listener who's got just a little bit of understanding about blockchain, but has heard a little bit about it, maybe doesn't know enough, tell us exactly what is it? How is it going to change a business or a company? What's in this for blockchain?
Well, let me sort of tell you a little bit about how it originated. So blockchain technology started out as the system that was invented really to support the Bitcoin network. Most people have heard of Bitcoin. It's the first cryptocurrency.
Right.
And what happened was that people looked at this technology that was used to support Bitcoin, and they realized that it had uses in other areas, in other ways. And sometimes these uses are quite different from the original use, which is for cryptocurrency. So I personally define blockchain, and I think you might find some disagreement among different commentators, but I think it's a technology that had 4 key innovations. Now, not all of these were created by the author of Bitcoin, but what he did was he put them together in a way that was novel and that other people have found useful. So those 4 are digital signatures to authenticate transactions.
Okay.
A distributed ledger that records transactions in blocks, hash values that link the blocks together in a way that makes them unchangeable and immutable. And then 4th, finally, a consensus mechanism that allows the different ledgers that people are maintaining to stay in sync. Those are the 4 elements of blockchain technology.
You want to step through the 4 one at a time and talk about how they apply?
Sure. So digital signatures, what that is it is a way of authenticating a transaction in a way that is not forgeable. So in the Bitcoin system, if I'm sending you 1 Bitcoin, we need a way that proves that I've actually authenticated and authorized that transaction on the blockchain that will be recorded permanently, that transfers the Bitcoin to you.
Okay.
The way that's done is through public and private key cryptography. And that's a mathematical way that creates a way for me to sign a transaction in a way that everybody on the blockchain can validate and verify. They can see that I'm the only one that was authorized to and did validate that transaction.
Okay. Go to point 2, second description of blockchain.
So blockchain has a distributed ledger. So if you want to go back to what the creator of Bitcoin wanted to do. So this was 10 years ago, 2008. There was a paper published by an author named Satoshi Nakamoto. And what he wanted to do was to create a digital cash system, but one that didn't have a centralized authority that authenticates and validates all the transactions. So one of the key innovations that he had to come up with was a way to keep track of transactions on the Bitcoin network. And so rather than have a central authority with a single ledger that authenticated and authorized all the transactions, he realized that you could distribute the ledger. You could give the ledger to everybody on the network and let them have their own copies and make their own decisions about validating the transactions. And that would create a system with a distributed ledger. So that's one of the innovations in blockchain technology.
This is what's referred to as a peer-to-peer system, I guess?
Right.
Okay.
That's right. In a centralized system, you have one participant that has more authority and more power to validate transactions than everybody else. So you might think of a bank, for example, in a role, if you're managing the checking accounts, or the automated clearinghouse system. There's a central authority that decides which transactions get authorized, which transactions don't get authorized, and it maintains the up-to-date ledger of all the transactions. You don't have that in Bitcoin. Everybody maintains their own ledger, and there's no central authority.
Everybody has their own ledger. Okay. So we've got digital signatures, a distributed ledger. What else? There were 4.
Right. Hash values, that's third. So when you record a transaction in this distributed ledger that everybody has a copy of, you want to make sure that it can't be changed later on. It has to be a permanent record. So Satoshi Nakamoto's idea was to use hash values to do that. When you record a block of transactions, you calculate the hash value. Hash values really work sort of like old-fashioned wax seals on an envelope. When you calculate a hash value, there is no way to change anything in that block without changing the hash value. And that would be something that would be visible to everybody on the network. And then you link the blocks together with the hash value. So the content of the block I'm recording now and the hash value I calculate will have a pointer to the hash value of the prior block. So if something happens if somebody were to want to change a prior block on the network, they would have to redo all of the blocks after that as well. That makes the blockchain immutable, unchangeable.
Unchangeable. That's hash. Okay. And part 4.
Consensus. You've got to have a way to make sure that if everybody has a copy of the distributed ledger of the transactions, you've got to have a way to make sure that those ledgers stay in sync. Mm-hmm. So what Satoshi Nakamoto originated in the Bitcoin system was a consensus system managed by proof of work by miners. Oh. So what he envisioned was that Bitcoin miners would perform a time-consuming computation, and they would record the results of that time-consuming computation in the block. And then when that block gets distributed on the network, it's not going to be accepted unless it has the proof of work included in the block. What that means is that if anybody were to want to forge blocks or redo blocks, not only would they obviously have to deal with the hash value problem that I mentioned earlier if they were trying to change the prior blocks on the network, but they would have to recalculate and recompute this proof of work for every block that they wish to create. And there's no way to effectively do that unless the person trying to create a false block had more computational power than everybody else, all the other miners on the network. So that was the security method that Satoshi Nakamoto used to assure that the network would remain the same. Now, one thing that I've talked about Satoshi Nakamoto,
Sure.
that's not really a real name. We don't know who the real author of the Bitcoin.
I was going to ask you, I'm going to say, okay, Mr. Nakamoto, is he a computer scientist, an economist? Obviously,
Right.
so this is just a made-up person?
Well, we still don't know who the real authors of the Bitcoin paper are or were.
Wow.
They chose a pseudonym, Satoshi Nakamoto, in order to hide their identities. Since we don't know who they are, and no one's ever talked to them, we don't know exactly why they did that.
Yeah, why? It seems like the potential staggering, and not to mention the financial windfall. Why would they hide?
Well, no one knows for sure. And there have been several efforts to try to locate and identify Satoshi, some of which have been pretty embarrassing failures, like the cover of Newsweek magazine a year or so ago that put the wrong guy on the cover. But if we ever find this guy, he's worth billions because he or they mined Bitcoin in the early days of Bitcoin when it wasn't worth much. And those Bitcoins that they mined back in 2010, 2011 are worth billions and billions of dollars. Now you can, because of the nature of the blockchain where everybody has access to the ledger, we can see the Bitcoins that Satoshi Nakamoto owns. And those have never been moved. They're still in the same place that they were when they were first mined. And they've never been moved or transferred, and they're worth billions of dollars.
I was looking forward to recording this program with you. I had no idea it was going to turn into this Hollywood-like narrative of this mystery in terms of who or what entity pulled all this together 10 years ago. This is fascinating.
It is.
Yeah. Okay. Back on track, I guess. One question. You've covered a lot of ground already, but I hear the term smart contract a lot in the context of these sorts of applications. Just briefly, what's a smart contract and how does that benefit us?
Sure. Well, once we had a blockchain system like the Bitcoin system, people realized that we could do more with a system like that than just move Bitcoins around. Mm-hmm. After all, everything is on the computer. So we can actually attach any programming code we want to a transaction. And we can do that while still having the advantages of the blockchain system. So we still have the digital signatures and the verified authentication. Mm-hmm. We have the unchangeable blocks on the chain. We have a consensus system. We have all those advantages plus any programming code we want. We can attach to transactions and have that code execute automatically. Okay. So that code is called smart code or smart contract code. And people have used that ability to create all kinds of interesting and complicated systems that implement functions using smart code or smart contracts that really would be difficult to imagine without an active human organization monitoring them. Automated exchanges that match buyers and sellers and implement options and derivatives on securities. Automated supply chain systems that track the raw materials and the stages of manufacturing. Voting systems that automatically implement results. And there are many more.
Yeah. In fact, you kind of segued into my next question. I was going to ask you to flesh this out a little bit. Let's talk about real world applications. You mentioned supply chain, financial securities trading, derivatives and whatnot. And you said voting, which is very interesting. Anything else that near term thinking these are practical applications that may come to markets and industries sooner rather than later?
There's a lot. The one example, for example, is real estate title systems. There's a historical system where, when you buy or sell a piece of real estate, you record a piece of paper in a registry, a physical paper registry, like our county recorder system. Those people are automating those kinds of systems on a blockchain that allows basically instantaneous access to the entire history of a piece of a parcel of land. So activities that today, title searches and the preparation of abstracts, those are tasks that can take weeks today. Right. But with a blockchain system, if everything is implemented automatically, they can be produced in seconds. And there are people using blockchain systems to do real work. Overstock.com, which is a company a lot of people are familiar with, has actually issued a class of securities that's traded on a blockchain.
No kidding.
And the trade can be cleared in just one day rather than the 3 days. And really, they could be cleared instantaneously, except for the additional safeguards that the SEC has required, including going through a broker.
Right, right. Well, this sounds great and fascinating, but there's nothing's perfect. There's no panacea, really. Are there limitations or inherent disadvantages to trying to apply blockchain? Are there instances where it's a bad idea or wouldn't work?
I think so, yes. It's not a panacea. And I see two significant disadvantages from a technical point of view to blockchain systems that people are encountering. One is that blockchain systems typically use a lot more computational time and resources than centralized systems.
Mm-hmm.
Blockchain systems replace the trust that we have in a central authority with the kind of mathematical cryptography that I've described that goes into a blockchain system like Bitcoin. Well, to do that, it takes extra computational time, extra computer resources, storage, network communication. Those things are usually way more expensive in blockchain systems than they are in centralized systems.
Okay.
So the other issue is privacy.
Sure.
Everybody in a blockchain, everyone on the network has to have a copy of the entire ledger of all transactions. So that makes it not impossible, but it makes it challenging to try to use blockchain systems if some of the data on the blockchain needs to be private, if some of the data needs to be kept away from the public or kept private to certain kinds of people. People have proposed blockchain systems using healthcare information, for example.
Right.
That's not easy to do. You've got to design it to be able to keep confidential what needs to be confidential.
Anytime a new technology is being widely adopted, it seems like privacy is always an issue because they're still trying to figure this out and no system is foolproof. Are there other potential areas of liability for a company trying to use blockchain besides privacy and data protection?
Yes. One issue is technical risk from the smart code and smart contracts that we talked about. So when you write this code, and this is code that's going to automatically execute transactions, it could be code that handles value worth millions or billions of dollars. Any programming code is subject to mistakes, errors, bugs. So this has actually happened in smart contract code. There have been bugs that have led and mistakes that have led to vulnerabilities or that have led to the inability to operate the way that the code is assigned. So we're putting more reliance on code. It makes the potential for bugs, mistakes, and problems more of a risk.
Sure.
And then there's legal risk, of course. This is a brand new technology. The legislators, the regulators are just now trying to understand what kind of laws, what kind of regulations we ought to have to apply to the technology. And they're coming up sometimes with different results. In Wyoming, for example, they're trying to encourage blockchain technology. They passed a law a year ago. They actually passed 5 separate laws to encourage the technology. One of them says that you can have something called a utility token, which is a type of cryptocurrency like Bitcoin, but you can have a utility token that is used, for example, to get access, buy things on a blockchain system or get access to resources on a blockchain system. That's not a security. Mm-hmm. Well, that's fine for Wyoming, but the SEC might well have a different view, and in fact, has expressed different views.
Sure.
So I think we're going to see those kinds of inconsistencies in legal risks as people get.
When federal and state regulations aren't aligned, I guess that's the right word, that can slow down innovation and wider spread adoption, right? So that's a risk, I think.
That's right. And that's exactly right. That's the risk I'm talking about, is that if there's legal uncertainty about whether something's going to be treated as a security, then people are less likely to want to use that technology.
Interesting. It has been a very eventful time. Boy, that's an understatement in the whole blockchain space. What do you see coming in the next year to 18 months in terms of the entire blockchain movement, if that's the right word?
There's an enormous amount of development going on now. And so what I think we'll see in the next 18 months is some significant implemented blockchain projects that are going to be widely publicized and successful. And I think that's going to give tremendous impetus to the use and adoption of this technology. The most likely area, I think, is financial technology.
Okay.
That seems to be the most focused on area for the use of blockchain technology. It's actually the first area it's related to cryptocurrencies, but it's using blockchain technology to handle financial transactions. For example, is the Ripple company, which proposes using blockchain technology to streamline foreign currency transactions among countries. Mm-hmm. So that's just one example. There's the Corda project by the R3 company, which can implement a smart contract system to handle all kinds of financial transactions like option contracts, things like that. So I think that we're going to see pretty widely publicized developments in that area.
Absolutely. Like I said, a very exciting time. Hey, Jim, thanks for being with us today. This has been great. Let's do this again, maybe early next year. A few more months go by. We'll just watch all this evolve. It's a fascinating scenario and a great promising technology. And congratulations again on the book.
Thanks. We appreciate it very much.
You can find Jim Cox's entire bio on jonesday.com. Learn about blockchain for business lawyers at americanbar.org on the Shop ABA tab. Get all the information on the book there. Listen to Jones Day Talks on Apple Podcasts, Google Play, and Stitcher. If you like what you hear, please rate and review. I'm Dave Dalton. You've been listening to Jones Day Talks Technology. We'll talk to you next time.
Thank you for listening to Jones Day Talks. Comments heard on Jones Day Talks should not be construed as legal advice regarding any specific facts or circumstances. The opinions expressed on Jones Day Talks are those of lawyers appearing on the program and do not necessarily reflect those of the firm. For more information, please visit jonesday.com.